Hi everyone and welcome to Smart Culture Education. This is the place where we make learning simple, clear and engaging. If you're new here, don't forget to subscribe so you can join us on this journey of mastering maths, science and more.
Let's have a look at question 13. The diagram shows a circuit including a 12-volt battery and two identical lamps. When the switch is closed, the ammeter reading is 2.4 amperes. Each lamp has a resistance of 3 ohms. Calculate the power supplied to one lamp. Now, how can we go about answering this question? So one thing that I want you to take note of is the fact that the two lamps are drawn side by side. So here we have a parallel branch. And then we have series over here with component Q. And then we have the ammeter. Okay, so what we are going to do first is we are going to calculate the total circuit resistance by using the ammeter reading. So we know that the ammeter reading is 2.4. Am I right? How do I know this? It's given in the question. So we can say that our total is equal to the voltage over the current. So it's going to be 12 divided by 2.4. And if you punch this into your calculator, you will get 5. Okay, let's quickly recap. How do I get this formula over here? Remember this triangle that we've learned about previously. I'm going to draw it over here. So this is your voltage, this is your current over here, and this is your resistance. So if you want to work out the current, you divide the voltage and the resistance. If you want to work out the resistance, you divide the voltage and the current. If you want to work out the voltage, you multiply the current and the resistance. Okay, step 2. Now we focus on the equivalent resistance of the parallel lamp pair. Okay, now we know that each lamp, and I'm going to zoom in, we know that each lamp has a resistance of 3 ohms, right? 3 ohms, 3 ohms. So let's quickly work out the parallel equivalent. Plus 1 over 3, that gives me 2 over 3. And now I have to invert it, right? So 1 over RP is equal to 2 over 3. Now I have to invert both sides, so that means RP is equal to 3 over 2, and if you write that as a decimal, it will be 1.5 ohms. So we don't need Q, we only need the voltage across the lamp branch. Okay, so in step 3, I hope that everyone is still following. In step 3, we are focusing on the voltage across the lamp branch. So it's a series chain, so the series current 2.4 flows through the branch as a lump of 1.5 ohms. Okay, so let's see. So the voltage of the branch is equal to the current multiplied by the resistance of the lamps. So that will be 2.4 multiplied by 1.5, and that gives me 3.6 volts. Okay, so as you can see, this formula over here also comes from this very, very handy triangle. Okay, so in parallel, each lamp gets the full branch voltage. So the voltage of one lamp is equal to 3.6 volts. Now we are going to work out the power in one lamp, because that's what they wanted us to do. Calculate the power supplied to one lamp. So now we are going to work out the power in one lamp in step 4. Okay, so we can say that the power is equal to voltage squared over the resistance. Now, the voltage is equal to 3.6. How do we know that? We just calculated that in step 3, and we have to square it. Let me just rewrite this. We have to square it. And what is the resistance? We worked that out as well. It's 3. It's given here. Each lamp has a resistance of 3 ohms. Now, what is 3.6 squared? Let's quickly work that out. 3.6 squared is equal to 12.96. 12.96 divided by 3 gives us 4.32, and the unit is watts. Okay, so now we are going to round it to 2 significant figures, so the final answer will be 4.3 watts. Okay, there's also another way that you can get the answer. I'm going to do that in orange over here. So to find the current in one lamp, I'm going to write I for current, and then I'm going to write lamp over here. You can use the handy triangle. I is equal to V over R. And what is V? V is 3.6. We worked it out in step 3. What is R? R is 3. It's given to us. Each lamp has a resistance of 3. Now, 3.6 divided by 3 is equal to 1.2 amperes. Okay, so there we have the current, and now we use this formula. The power is equal to the voltage times the current. Now, we know that the voltage is 3.6. We worked it out in step 3. And we know that the current is 1.2. We just worked that out. 3.6 multiplied by 1.2 is equal to 4.32 as well. So it doesn't matter which method you followed as long as you've got the answer of 4.3 watts.
Thank you for watching today's video on Smart Culture Education. If you found it helpful, don't forget to hit the like button and subscribe to the channel. And if you want to stay updated, tap the notification bell so you never miss our next lesson. See you in the next video.